this video acts as an introduction to the power in this whole chapter. This introduce you with the concept of power and what we're gonna go through in the subsequent videos. Alright, so we're gonna just start out with what are the power source should you use for your system. Alright, whether do you use the main or a battery. Alright, this is the thing that we're gonna talk about quite rigorously. So in the next video we'll talk about the main supply. Alright, then after that we'll talk about the battery supplies. Then I'll talk about the other issues that with regards to power supplies and what are things to take note when you design a circuit in terms of power. Alright, so we're going to break down into a few portions and talk about it. Right. So just a quick concept of sources of power, because what type of powers are there. So we say that there is main and battery, but just an introduction to what are the sources of power, in the sense that why do we in a certain sense, what are the key issues that lead us to talk about sources of power, right? In order to explain sources of power, I will use sources of banana. Alright, you can get the banana from your supermarket, or you can get banana from the banana tree, or you can get banana from your neighbor. Alright, you steal from your neighbor. What drives you to take in what drives you to go to the supermarket and buy, and what drives you to go to the banana tree and get, and what drives you to steal, it all depends on your needs. Alright, it all depends on your needs. Alright, so if you go back to the slides itself, the source of power in our case is only what? The main power supply and the battery. And the need is often talking about the portability, the need for portability or not. So if you want something that is portable, then we will most likely use the battery. If you're talking about those that you don't need portability but you want a high power source and whatever, then we will talk about the power supply unit, PSU. Alright. Nonetheless, there are also other possible things like I don't know what the hell is this, but then after that, the wind power, fuel cells and things like that. Besides the battery, besides the power supply unit, you may also have other method of getting your power, right? After you choose your power supply, whether is it a main power supply or whether is it a battery, then you're going to choose how to design your circuit, right? So this is something that we're going to talk about later on also. So in order to choose your circuit, you're going to choose the voltage that is being used in your circuits, right? So normally in the past, alright, the logic is ran at 5 volts. Alright, the meaning of why 5 volt is inefficient or why is it nuisance, alright, is because normally for a battery, you're talking about 1.5 volt batteries. Alright, so in order to run a 5 volt system, you need to have 4 batteries, so you have about 6 volt. Alright, so 6 volt is too high for a 5 volt system, correct? If your machine is running at 5 volt, then if you have to put in 6 volt, you're going to kill your machine, correct? So therefore, they always will want to use a regulator. Alright, so a regulator will regulate the 6 volt into 5 volt so that the 5 volt can be used inside the machine. Okay? Why is it nuisance for the 5 volt is because you know that the battery is in terms of 1.5 multiple, right? Because 1.5 times 3, then you have 4.5 volt. Alright, you can also design the 3 volt system. But why you want to do 5 volt? Alright, so they say actually this 5 volt is actually quite useless. Alright, and therefore at the end of the day, they actually usually supply a full 9 volt battery also. As you can see, the 9 volt battery is in terms of for example 1.5 volt. If you multiply by 6, you'll get 9 volt. You see, it's a multiple of 1.5. Alright, so normally people start to use the multiple of 1.5 instead of the classical way of representing a volt in terms of 5 volts. Alright, so which is very tough, because you will require a regulator, which is you require one more component, not enough, like really not efficient, right? So therefore yeah. Then last but not least, alright, don't take it as this is the full video for power, but this is just a introduction to all these things. Alright, just a quick introduction to give you a concept, so later on when we talk about things, it's easier for you to understand. Is that the modern logic, alright, is that we thought that if you have a 3 volt system or a 3 volt machine, if you put in a 2 cell, which is 1.5 times 2, which is 3 volt, correct? So if you have a 2 AA battery, alright, then you can feel very happy already. but it's sometimes not as simple as that. It's because although this is running at 3 volt, alright, you may also have other components that runs with other stuff. Alright, if this 3 volt is connected to other stuff that requires other voltage and things like that, alright, maybe 3 volt also lah, or maybe 4.5 volts, etc. So this particular 3 volt is connected to other machines. Alright, so you will require a higher voltage may be needed for parts of a system such as LCD, etc. Alright, so you may require a little bit much more power so that you can generate other smaller components within this system. So this system itself is 3 volt, alright, but within itself there is other stuff that requires slightly more power. Yeah, this part sucks lah. But anyway, ignore this part. Alright, is that within your 3 volt itself, or you may have little components that may require more power. Alright, so you may have a bit slightly more, like about maybe 3.5 volt or whatever. Alright, things like that. Yeah lor. That one is one way of explaining. The other way of explaining is that 1.5 volt times 2 is equals to 3 volt, correct? And your machine requires 3 volt, okay? But the main system that requires the amount of voltage is actually about 2 volts, while the peripheral components, alright, requires 1 volt. Alright, for example, your particular system over here machine, the whole thing requirement is 3 volt. Alright, in order to run the machine, at least your A, alright, has to be on. So it's about 2 volt, for example. Okay, for example only. Then your C component is 0.5 volt, B is 0.5 volt. Okay, so minimally in order to power up your machine, alright, you may require 2 volts only. Okay, so I repeat again, in order to power out your whole machine, you may require 2 volts. But within its own system, alright, there is other stuff. If adding up together, it becomes 3 volt, as you can see, right? And if you add up all together with this one, you'll get 3 volts. Alright, so so normally when they specify the machine's voltage, they actually specify the full system when it is running full. Okay, so you require 1.5 volt times 2 in order to run a full system. Okay, and as time goes by, your battery may actually drain, right? So your 1.5 volt may actually drain to maybe 1.1 volt, correct, for example. So if 1.5 volt times 2, you'll get 2.2 volt. So this 2.2 volt can at least power up this component, but the rest of this component can be barely power up. And sometimes you may have some system malfunctioning because you have insufficient supply already, because your power supply is getting lesser and lesser. So you need to change battery, right? For example, if you play your Game Boy, right? Last time you play your Game Boy, alright, when you put in the full power, your screen is very bright, correct? Your screen is very bright. But as time goes by, when your battery is being drained, or your screen is actually getting dimmer and dimmer, alright, things like that. And yeah lor. So this is one way to actually say that there may be other components that comes within itself that may contribute to your power lah. Alright, that may requires you to tap in more power and things like that. Therefore, this is another way to explain the voltage. Besides just now what I've say, what higher voltage may be needed for parts, whatever. So instead of 3 volt, you may require more than 3 volt. Alright, I don't think this is quite legit. Alright, so I'll leave you to think about it. So there's no right or wrong, just for you to decide yourself. Alright, so in the future, if you need power, then you can actually consider these two properties or these two factors that I just discussed. So then you can know what to design or how to design your battery. Alright, so this is still your introduction. Alright, so I didn't go through much with this one. So in the subsequent videos, I'll talk about the main supply, the battery supply, and other issues. Okay, so see you there.